Hello friends, this is Dr. Siva Nagaraju, Associate Professor from EC Department, IARE. Today we are going to discuss about the generation of VSB and demodulation of VSB also. And lastly, we are going to comparison of AM techniques. Why? Because from previous videos we discussed a lot of modulation techniques. One is the standard AM and DSBSZ, SSB, and the last one is VSB. So we are going to compare all these techniques. Okay. So now we are going to enter into our topic generation. So this is the block diagram, what we require of this generation of VSB. So we are having product modulator, local oscillator, sideband shaping filter. So here we are giving two inputs to the product modulator. One is M of t and another is C of t. Already you know M of t is the message signal, or you can also call it as modulating signal. Modulating signal. So M of t, which is equal to AM cos 2 pi FMT, and C of t, it is a carrier signal, which is equal to AC cos 2 pi FCT. So these two signals which are going to apply to the product modulator, and the product modulator which produces DSBSC wave, double sideband suppressor carrier. Already we see that in the generation of DSBSC also, but in VSB we are giving this DSBSC wave to the sideband shaping filter, and this filter produces our VSB-SC wave, which is a sideband suppressor carrier wave. So already we discussed in the time domain description of VSB. In the time domain description of VSB, we use this sideband shaping filter and this transfer function of this filter. Already we applied some mathematical operations, and finally we produces the mathematical or time domain description of this VSB. Okay. So the output of product modulator is the DSBSC wave and is given by S of t, which is equal to AC cos 2 pi FCT into M of t. So this is just a product of message signal and the carrier signal. Now we are going to apply this DSB to the sideband shaping filter. So this filter will pass the wanted side, and it is and then vestige of unwanted sideband. So that means one band fully sent and another band is some vestige, some part. So that is called as vestige. So now the transfer function of the filter H of f and the spectrum of VSB modulated wave is given by S of f, which is equal to AC by 2 of M of f minus FC plus M of f plus FC into H of f. So here H of f is a transfer function of this filter, the sideband shaping filter. Okay. And now we are going to discuss about the detection of VSB. So in the detection or demodulation of VSB, here also said we are giving this VSB-SC wave, residual sideband suppressor carrier wave, to the product modulator, and another output is C of t, that is a carrier signal, which is equal to AC cos 2 pi FCT. Here the synchronization is must. That means what we use as a transmitter, the same carrier is used at the receiver also. So the output of the product modulator is V of t, and again it is applied to the low pass filter. Whereas in generation we used sideband shaping filter. Why? We require the full part of one band and some part of other band. But in the detection we are using low pass filter. That means it allows only low frequency components. And finally we got the demodulated output. So the detection of VSB modulated wave can be achieved by passing VSB wave S of t through a coherent detector. So V of t is AC cos 2 pi FCT into S of t. S of t is nothing but this VSB SC signal. Now we are going to apply Fourier transform on both sides of above equation. We get to this V of f, which is equal to AC by 2 of S of f minus fc plus S of f plus fc. Already we've seen that how this Fourier transform is coming. In place of S of t, m of is there. Here getting m of f minus fc plus m of f plus fc. So here we're getting S of t, that is a modulated version of VSB SC signal. But what is S of f? S of f, which is equal to AC by 2 of m of f minus fc plus m of f plus fc into h of f. What is h of f? That is a transfer function of that filter. So here we can write S of f plus c and S of f minus fc also. So substituting the above two equations in V of f. So once you go to for this V of f, we're having AC by 2 of S of f minus fc. So we know that S of f minus c fc term, and we know that S of f plus fc term. So just in this S of f, you substitute those values you can get. In the place of f, you can substitute that we're having S of f plus fc and S of f minus fc. So finally you can substitute these two equations of V of f. You get this V of f, which is equal to s squared by 4 m of f into h of f minus fc plus h of f plus fc plus s squared by 4 into m of f minus 2fc into h of f minus fc plus m of f plus 2fc into h of f plus fc. So this is the frequency domain after applying a Fourier transform on V of t. Okay. Now we are going to compare the different modulation techniques. So one is a DSB FC full carrier. It's nothing but our AM, standard AM. Another one is a DSB SC, and another one is SSB. The last one is a VSB. So here we are taking the left hand side, that's a parameter of comparison, which parameter is considering. So first the carrier suppression we use. So in this DSB FC, so full carrier. In standard AM, we not suppress any carrier. And in DSB SC, we are going to suppress carrier fully. And SSB SC also, we are going to suppress the carrier fully. And sideband suppression. So in SSB, we are going to suppress only one sideband completely. And whereas in DSB FC and DSB SC, no sidebands suppressed. Whereas in VSB, one sideband suppressor partially. So the bandwidths, now the parameter is the bandwidth parameter. So The bandwidth for standard AM is 2 FM. DSB also same. But in SSB, we are sending only one sideband, so it goes to half. So 2 FM by 2, you get FM. Whereas in VSB, we are sending one band fully, another part of sideband sending. So that means it is more than that of SSB. Another is transmission efficiency. So here the maximum transmission efficiency is in SSB. And remaining is moderates. One is a DSBSC also moderate, VSB also moderate. And the efficiency is very less in the standard AM. So already you find out this transmission efficiency. That is a mu square by mu square plus 2. When mu is 1, perfectly modulated, you're getting 1 by 1 plus 3. Sorry, 1 by 1 plus 2, that is 1 by 3. So that is 33.3% of efficiency from the standard AM. And the applications. One is radio broadcasting, that is standard AM. DSB also radio broadcasting. And SSB is used as point-to-point mobile communication. Whereas VSB is for video signals, that is nothing but our TV. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.